Okay, so we've covered all the rules you need. Now let's try a tough problem. Let's try and prove De Morgan's law in one direction. So that is, if it's false to say that A and B is true, then one of them had to be false. So not A is true, that is A is false, or B is false. Okay, so we put the thing we're given at the top, we put our target at the bottom, and just by looking at this, it's not all obvious where we even start. There's nothing to break up, there's nothing to really do here. So in these last resort situations, what we can do is try and assume the opposite of our goal, and then somehow try and obtain false. So I'm going to assume the negation of not A or not B, and then somehow try and get to false. Okay? At this point, it still looks tricky. I'm not really sure where to go from here. So what we can do is we can look at this formula here and try and think of things that this is equivalent to. So if we have that it's false to say not A or not B, then that means if neither of these things can be true, so that means it can't be the case that A is false and it can't be the case that B is false, which means this thing, it ought to be the same as A and B. So it means that if we assume A, we should hopefully get a contradiction with this. So if you're trying to see like what sort of random assumption you have to make, you can maybe argue yourself via truth tables or otherwise. If this formula is true, what should that say about A? And this should indicate that A is true. Okay? So let's try assume not A and see what happens. If I assume not A, then I can always logically AND something for free. So I'm going to logically AND not B. Not A or not B. And oh look, this statement here and this statement here contradict each other. So I can get false, and then I can get A by negation elimination. Okay? And I can do the exact same thing again. If I assume not B, I can OR it together for free with anything, so I'm going to OR it with not A or not B. Once again, these two statements contradict, so I get a false, and then I get a B. I have A, I have B, therefore A and B, and then this statement contradicts my original statement up here. I have not A and B, I have A and B, these two things contradicting get me false, therefore this assumption is wrong, and I have not A or not B as required. So that was a real tricky proof. It's done. We can fill in the line numbers, and then we can fill in our rules. It's really important you fill in the line numbers and rules. The proof alone is only halfway done, and you only get halfway marks without justification. 10, 11, 12, 13. Okay? This was given. This was an assumption. This was also an assumption. This was OR introduction of line 3, because I OR'd in the not B for free. These two statements 2 and 4 contradict each other, so I can use negation elimination, which is this rule here, on lines 2 and 4. Really it should be 4 and 2, because the one with the negation is on the second line, so it really should be 4 and 2. Assume not A, derive false, therefore A, by proof by contradiction. I assume not A, I got false, therefore A. So PC lines 3 through 5. And this case here is pretty much the same thing. So assumption or introduction, line 7. Negation elimination, lines 8 and 2, in that order, 8 and 2. I assumed not B, I derived false, therefore B. Proof by contradiction, lines 7 through 9. I have A, I have B, so A and B, by A and introduction, line 6 and line 10. Line 11 and line 1 contradict each other, so we have negation elimination by line 11, this is the P, and line 1, this is the not P. I assumed the negation of all this stuff, I obtained false, therefore I could drop the negation using proof by contradiction again. So I wanted to prove this, I assumed the opposite, I got false, therefore this thing is true. Proof by contradiction, lines 12, all the way, lines 2, I beg your pardon, all the way through 12. Okay? So that's a tricky proof, and these things do require a lot of practice, so I recommend you go through and try and prove this in the opposite direction. So try to prove that if you have not A or not B, then you can obtain not A and B. So have a go at that.